Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And before we get into today's episode, we don't have a sponsor. We're not going to sell anything this week, but we do need your help to grow. So if everybody listening could tell one person about our show, that would be fantastic. And it would help us out a ton because we need to grow in order to be successful. So if you could tell someone, anyone you know that's interested in dinosaurs or science about I Know Dino, that would be fantastic.
Yep, we would appreciate it.
This week, in our 274th episode, we have a bunch of news, including a new Allosaurus species and some new sauropod tracks, which might indicate swimming, and some other stuff. And we have Dinosaur of the Day, Haplocanthosaurus. But before we get into all of that, we always like to thank our patrons who keep our podcast functioning and keep us motivated to keep cranking out content. And this week, we'd like to thank Scotty, Megan Dixon, Kessler, Rhinosaurus, Morgan Eklove, Risa, Kelly, Manda, Laurasaurus, Timmy, James Pasco, Gabe, TRX Dinosaurs, and Michael.
Yeah, thank you so much. We really appreciate all that you do and all of your support, and we're having a lot of fun with all of the messages we get and the things that you share with us, so thank you. And if you want to join our growing dinosaur enthusiast community, then check out our page at patreon.com/iknowdino. We have for a lot of rewards.
Jumping into the news, our first paper we're going to talk about is the new species of Allosaurus. And this one was published in PeerJ by Dan Schur and Mark Lowen. We've talked to Dan Schur a couple times before.
Yeah, he's supposed to be retired.
He is, but he was working at Dinosaur National Monument, so you might be able to guess where this find is from. It's also kind of funny, when we were at the Tucson Gem Show, we saw a replica of Allosaurus jimmadseni for sale.
Yeah, they came out quick with that.
They did, but I think I know why. I'm going to get into that later.
Oh, okay. Mystery.
So jimmadseni, the species name, we all know Allosaurus, but jimmadseni is the new part. That's after James H. Madsen Jr., who excavated, prepared, and described thousands of Allosaurus bones from the Cleveland Lloyd Quarry. And you might remember the Cleveland Lloyd Quarry because it is amazing. It's a predator death trap is usually what people assume it is, because it's like 3/4 or 2/3 Allosaurus. So there's a ton of Allosaurus, and there's hardly anything that they would be eating unless they were eating each other, or who knows, but it's this weird area.
And there's a few theories about why that is.
Yeah, and it's just packed full of Allosaurus. So it was really helpful in learning about Allosaurus, because before we found that quarry, we didn't have a big group of them together. So it was pretty awesome. Obviously very important to Allosaurus paleontology. You may also know that the type species of Allosaurus is Allosaurus fragilis, and that's generally what all North American Allosaurus are typically considered by a lot of people, at least. Although the authors do say that there are at least 19 species of Allosaurus that have been erected since 1877.
That happens a lot with dinosaurs that were named in the 1800s.
Yeah.
Although 19 is still a lot.
It's a crazy number. I think on Wikipedia, it lists like 6. So yeah, there's definitely a lot that are probably less valid, some people, I think some of them aren't even really officially described. There's just somebody said like, oh, there's this new Allosaurus without actually showing any of the material. According to Schur and Lowen, though, they only think that 3 are valid: fragilis, europaeus, which is from Europe, and jimmadseni. And of course they think jimmadseni is valid because they're naming it in the paper.
Makes sense.
So in other words, they thought there were 2 before, the European one and the North American one, and now they're splitting the North American one in half. The authors say they spent 20 years studying, quote, virtually all North American Allosaurus material, end quote.
That's a lot to take in.
Yes, and it's spread out all over the place because the Morrison Formation is really big, which is where most of the Allosaurus is from. So getting into what jimmadseni is, the type specimen is Dino 11541. I just wanted to read that out because Dino is the alphanumeric part of the Dinosaur National Monument.
Oh, that's great.
That's pretty cool. They found that one in 1990. So you might wonder why it's been 30 years since they found it to when they named it. But when they found it, they found some of the right foot and vertebrae on the surface, and the rest of it was buried deep in a cliff. They actually ended up using explosives to get it out because they had to remove a ton of overburden. And after a few years of working on it, they eventually helicoptered out a 3-ton block of the Allosaurus body. Then they had to prepare it all out, obviously, and they were left with a nearly complete articulated body. And apparently they started from the end of the tail and started working their way forward, but it stopped at like the last or second to last vertebra before the head. And then there was no head. So they were hoping this whole time that as it curved around, because it's in the death pose, that there was all that rock there, that they would get to a head, and it wasn't there, which is kind of a letdown because the head is so important.
Right. After all that work.
Yeah. But the nearly complete articulated body is really amazing. It includes a wishbone and a complete set of gastralia, which is really uncommon. It also has a complete articulated left hand, which I think might be the one we have, because we have an Allosaurus hand replica from Dinosaur National Monument. So
yeah, that's sense. A good one.
Yeah. The thing it came with doesn't say the specimen number that it is. Maybe I need to reach out to them and see if they know. And then they basically gave up on finding the head. They dug in a couple spots and couldn't find it. They went farther in towards where that last vertebra was sticking, and there wasn't anything there. But a little while later, they discovered that the fossil was slightly radioactive, about 3 times as radioactive as the background radiation.
Is that dangerous?
No, in general, it's like a super low amount of radiation, and this is compared to a super, super low amount of radiation. So it's one of those where it's like being around this bone. I guess if you laid on top of it all year, you'd get 3 times as much radiation as you got from all year somewhere else. But the amount you get just in the background is really low, so it's not dangerous at all. But it can be useful for finding the fossils. And the reason that they are radioactive is because they kind of concentrate uranium and vanadium from the surrounding matrix. So while they're fossilizing, obviously the way it works is they're drawing in minerals from the surrounding material and it's replacing the bone. And in that process, a lot of time it just kind of draws in some of these radioactive elements. So you can actually find them using, in this case, a shielded gamma scintillator, it's called. But if you're familiar with a Geiger counter, it's a similar thing. It's a little bit more specific because it only uses gamma radiation, whereas Geiger counters use any kind of radiation, or react to any kind of radiation, I should say. But in 1995, they went back with this new device. They basically mapped out the entire wall from where they were digging, and then they spent the off season analyzing the data. And then in 1996, they went back with where they thought the best guess of where the skull might be was, and it was exactly where they expected.
Cool.
Yeah, so it was about 2 meters away from where the last vertebra was. So the skull was really far away from, it's like 6 feet away from where everything else was lined up, and everything else was articulated, basically. So then just the head was shifted way off to the side.
What happened to that head?
I don't know.
Who cut it off?
Yeah, or what pulled it off. But it was also in really amazing shape. So it doesn't look like, something was chewing on it or something and broke it to the side. It's probably more just like while it was being buried in the whole taphonomy process, it just got moved over to the side. In any event, it's in really, really great shape. Basically, it's the left half of the skull in perfect shape, and then there's a little bit of the right half. So when they prepared it out from the side, and it just looks amazing. And they described it as the Mona Lisa of the Morrison Formation.
Is it smirking?
No. Oh. But it does have its mouth closed, so it has that in common.
Cool.
It'd be better if the Mona Lisa was kind of in profile, since this is very much a profile situation. But it's still really cool. And one way to show how well preserved that one is, it also includes the eye bones from the sclerotic ring.
Oh, wow.
Which are pretty uncommon. They're not articulated, though, unfortunately. I don't know how often we get articulated sclerotic ring.
It's a very specific fossil.
Yeah. This one's really cool, though. So that's Dino 11541, and that's the holotype. So that's the real definition of what Allosaurus jimmadseni is.
Right. The one you compare all other bones to.
Yep. And there are a lot to compare to it, because if everything else up to this point has been considered Allosaurus fragilis, or maybe one of other 19 species, you have to have a good exact thing to compare it to. And since it has basically a complete skull, because it's going to be a mirror image, you have a great basis to compare to. And there's also the full body if you need to use that. But really with Allosaurus, we're mostly comparing skulls. So there were some other Allosaurus when they were doing their 20-year review that they looked at and thought also belonged to jimmadseni. One of them is MOR 693, also known as Big Al.
Big Al, the one they've made movies about.
Yeah, very famous. Maybe the most famous Allosaurus is now considered Allosaurus jimmadseni, at least according to these authors. And I think that might be partly why they made it another species of Allosaurus rather than making it a new genus. Because if Big Al was now all of a sudden, like Thanos or one of these other names.
But isn't it also a matter of how unique is it too?
Yes. So that's probably why they went with it. And there's also already that European Allosaurus species. So maybe they figured if we're going to consider that one a species of Allosaurus, this one is close enough to that we should just also make it a different species. But that's the whole lumping and splitting thing. And you can go a million different ways with that. And in addition to Big Al, they also included SMA 0005, also known as Big Al 2.
There's a Big Al 2?
Yeah. That one includes skin impressions from the tail and is also very complete. So that's a really popular Allosaurus as well. They also included a juvenile and adult from Wyoming and, quote, all Allosaurid material from the Dry Mesa Quarry, Colorado, curated at BYU, and unpublished material from the Malin Quarry were posited as casts at the Natural History Museum of Utah, end quote.
That's a lot of material. But they would know. They spent the last 20 years going through all of it.
Yeah, I like that they just lumped in whole quarries. Like, yep, all that stuff is jimmadseni. Everything you found there, that counts. So those would all be considered paratypes, I think, at this point, because it's in the original paper where they're naming it. But maybe they would just be considered more of the same genus. I'm not sure exactly how it settles out. But in any event, you can't use those materials to compare different Allosaurus. You have to use the one that was found near Dinosaur National Monument because that's the real holotype. Allosaurus jimmadseni is on the older end of the spectrum for an Allosaurus. It's about 155 million years old. I think the range is like 145 to 155 because that's about the range of the Morrison Formation in general. So this is like an earlier Morrison Formation find. And the paper has lots of excellent comparison pictures showing the difference between the three species that they consider valid. I would say overall, if you're just looking at it with a non-Allosaurus expert's view, jimmadseni's horn-like bumps above its eyes and the crests on the top of its snout point a little bit more upward, whereas fragilis are a little bit more on the sides, kind of sticking outward a little bit. So that's kind of the most obvious difference, as well as the fact that jimmadseni has a little bit more of a pointed tip on the end of its snout than fragilis is a little more boxy at the end.
Or you look at it and you say, which one looks more like the Mona Lisa?
Well, that one prepared one definitely does. Although that one can be a little bit harder to compare because its mouth is closed. And a lot of times when they're recreated or displayed, they have their mouth open. So that can make it a little tricky. The fact that jimmadseni, too, like the main picture of it is that one holotype with its mouth closed, reminded me a lot of Nanotyrannus. Not because it looks particularly like a tyrannosaur, but because they're splitting out something that I'm not sure everybody's going to consider valid.
Have there been debates around this already?
Well, the paper just came out, so we have to wait to see how people respond to it.
Right. But you were saying you had a theory on why the Tucson Gem Mineral and Fossil Showcase had this replica already.
Oh, yeah. I think it was just a replica of Big Al.
Oh, and that's how they got it out so quickly.
Exactly. So it probably used to say like Big Al Allosaurus, and then they just switched it over to Allosaurus jimmadseni.
Right. I'm not as familiar with what Big Al looks like compared to, say, Stan the T-Rex. So
yeah.
Would have no idea.
Yeah, me either. But I should clarify too, though, with my comparison of Nanotyrannus, I don't think anyone is considering jimmadseni to be just a juvenile version of Allosaurus because Big Al is definitely not a juvenile.
Big Al had a rough life.
Yeah, that he or she did. After staring at these pictures, though, for a long time, the comparison pictures between fragilis and jimmadseni, I think jimmadseni looks more like my mental image of an Allosaurus than Allosaurus fragilis does. Maybe I just saw a big owl a bunch when I was a kid. And so that's my vision of an Allosaurus.
Could be.
So to me, it's almost like Allosaurus fragilis is the new species, even though that was named over 100 years ago.
Right. And that's the type species.
Yeah. And I was a little bit concerned that this was going to mix up the whole Allosaurus fragilis getting a new holotype, the neotype thing that's been going on. But I think it's still okay because they mentioned which specimen that was, and that wasn't included in their, names of jimmadseni. So I think that one's sticking with Allosaurus fragilis. So it should be okay. But the fact that we're kind of throwing a little bit of the fragilis material into question and now calling it jimmadseni, hopefully that doesn't.
Well, there's still a lot of fragilis material.
Yeah.
And actually, if you want to hear more about Allosaurus and specifically fragilis, because I think that was a lot of what that dinosaur of the day was, then you should listen to our episode 25, which is all about Allosaurus.
And hopefully that's not really out of date now with this new discovery. It shouldn't be too bad.
Well, actually, so I was just looking at our show notes, and jimmadseni is in there. So they must have been talking about this for a while now. It's officially published.
Yeah, because that was like 5 years ago. That's pretty crazy.
Mm-hmm.
Good job, Sabrina.
Yeah, thanks.
That was early days, too, when we were not as good with the research.
Or maybe we were getting better because this is a long one.
So if you're looking for a long Allosaurus description, check out that episode 25. There should also be more research coming out about jimmadseni because they pointed out that this paper only looked at the skulls. So there's a whole bunch of Allosaurus body material to cover, and they say they're going to do that in a future paper. And in that paper, they're also going to explain why they synonymized all these other ones and only consider 3 valid. So something to look forward to if you're an Allosaurus fan. I guess Dan has retired from Dinosaur National Monument, but very much not retired from paleontological work.
I think that happens a lot in this field.
Yeah, I mean, people just love it so much. Why would you ever stop?
Mm-hmm.
Up next is our paper on sauropods potentially swimming, at least the tracks of them potentially swimming. So I want to go back in time first before I talk about this paper. Back in 1940, there was a fossil collector named Roland Bird who visited some reported quote-unquote elephant tracks in Texas. And when he went out there, he quickly realized that they were not elephant tracks and were in fact sauropod tracks. And he described about 13 tracks that he found there to Barnum Brown in a letter saying, quote, "I saw them while we were still 100 feet away, a double row of large round circular prints, without a doubt made by a sauropod, but as I interpret them, made by an individual while swimming. They were all typical 4 feet impressions, as if the animal had just been barely kicking the bottom," end quote. And this has been described as sort of punting, I think they call it, where they kind of kick off the bottom of the lake and reach the surface and sort of do that process, or otherwise sort of doggy paddling with just the front legs where the back legs are kind of floating up.
Oh, that's fun to imagine.
Yeah, so it's kind of a weird thing. And obviously, in order for that to work, they have to have longer front limbs. So we're talking about stuff like Brachiosaurus, which was around in North America, so it's not too crazy. But since then, people have proposed that maybe those tracks were just under tracks.
What are under tracks?
So when you leave a fossil footprint, you can leave a footprint from any depth of the print itself, which is kind of hard to imagine unless you think about how much a sauropod weighed and how deep its foot might have gone into the sediment. So if you imagine a Brachiosaurus with its big front legs and a lot more front heavy, and it's walking along, its front legs are going to sink deeper into the sediment than its back legs. But then if in the process of preservation, it shears off, say, the top half of the tracks, you might shear off all of the hind feet, but none of the front feet. So then you end up with this look that you're getting just the front feet, but really what you're getting is the bottom half of the front feet, and you're not getting any of the back feet because they were just higher up. They didn't leave as deep of an impression. So that would be an under track. Kind of a weird thing. There's been some studies recently to show how you can tell the difference between an under track and a regular track, but a lot of that has to do with theropods and how they kind of pull their foot out of the muck and it leaves these weird points and stuff. But with a sauropod, a lot of times they just leave this big divot crater. And I think there's a little bit less to go on in some of those cases. But if we flash forward to 2007, there were some new tracks found from the Glenrose Formation, and that's what this paper is about. It was written by James Farlow, Bob Bacher, and others, and published in Ichnos. And it was kind of funny. They talked about how Farlow and Bacher were both contacted separately by the person that found the fossils, and were both working on it separately without knowing that the other one was doing it, until one day one of them reached out to the other to see what they thought about it. And they were like, I'm working on that already. What are you doing at my quarry? So then they started working on it together. So then they ended up just co-publishing.
At least it didn't turn into some rivalry.
Yeah. It's kind of funny, though, because they had already done a lot of work. So they had two different versions of pictures of the whole track site. So one of them had taken it with a camera and kind of stitched it together. And the other group just used a drone and took one picture. It's like you could have saved a lot of time if you knew the guy that had the drone and just used his picture.
Or you get different angles.
Yeah, they might have a little more detail in the non-drone one, I suppose. But it's still pretty funny that they were working on it separately for so long.
I didn't think that happened in present day.
Yeah.
You hear about it all the time. Back in the day, scientists don't always know, when something got renamed, and then they rename it again, and then you have 5 different names for the same thing.
Yeah.
And like, okay, that makes a little bit of sense. It was a little harder to communicate quickly back then.
But in the age of email, it's
Yeah.
a little surprising. Yeah. So these tracks were found, like I said, in the Glenrose Formation, which is north of San Antonio, Texas, and it is a really cool trackway. So there's, quote, 3 parallel Manus-only sauropod trackways, end quote. And they call it the Coffee Hollow track site.
That's an interesting name.
For it. Yeah. I think they said it was named after like a burro or something, or some kind of like award-winning animal. It was interesting. There are at least 52 tracks there. It reminds me a little bit of the picket wire sauropod tracks in Colorado, especially in that the ends of the trackway are buried in more dirt and rock. So if we excavated more in the direction, you probably find more tracks even. So it's massive already, but there's probably even more of it. Each of the tracks is only a few centimeters deep, which is pretty surprising for a sauropod track, because a lot of the times those are crazy deep. But in this case, that gives you the question of, were they just barely touching the ground? Like, were they swimming and just kind of scraping along the bottom? Or is this an underlayer, that under track like we were talking about? They think that since some of the tracks have a lot of material kind of pushed up towards the back of the track, that's an indicator that it was probably a surface track and not an under track. Because if you're walking and you're kind of pushing up a little heap behind your feet, and then you're sheared off the top layer, you probably wouldn't see that heap so much. It's their basic logic there. They also got kind of lucky in a way that one of the prints was broken, because it allowed them to easily take a piece of the track out to study, and they could then like polish it down and look at the microscopic structure and all this stuff. And they basically found that it was in a closed lagoon based on their analysis. And that's because of the aquatic fossils and algae and stuff that seem to be in the layers of the sediment. It's pretty cool that they can figure that out. In order to determine if the tracks were made by a swimming sauropod versus just a sauropod that was walking normally, and for some reason we only have the front feet, what they decided to do was compare the track makers from this Coffee Hollow area to other known sauropod track makers where we do have the hind feet, and then just look at the front feet from those ones that are walking with the hind feet.
Oh, yeah, that makes sense.
Yeah, and you can kind of see like what kind of pace they have, how far apart the feet were, all that kind of stuff. And when they did that, they found that one of the 3 trackways was a little weird, but the other 2 looked pretty normal. So, in other words, doesn't look too swimming-y. But they did say that they couldn't rule that out. So it doesn't look like they were swimming, but maybe they were. It's not really the greatest answer. But to me, interestingly, either way, the dinosaur that made these tracks was front heavy with longer forelimbs, because otherwise there's no reason you would only have front tracks going, unless it was doing a handstand.
Yep. Or a wheelbarrow. Something was holding its back legs.
Yeah. At first, when I read it, I was thinking that it was the 2 back feet, and it was like how you like to think about the baby sauropods running on just their hind feet.
But on the front feet only. Yeah, it's weird.
It is weird. Another possibility, too, is that one of the track makers, or maybe all the track makers, might be a new dinosaur, and that could explain why its gait is different or why these three individuals had these tracks that didn't include their hind feet.
In other news, and maybe this isn't news if you live in the UK, after Storm Ciara, which had 60-mile-per-hour winds and heavy rain, it's a big storm, they found a new dinosaur footprint on the Isle of Wight on a beach in Sandown Bay. And this track is 130 million years old, probably of a large theropod. At the time the track was made, the dinosaur would have walked in front of, quote, a range of low forested hills, while ahead lay a flat floodplain landscape dotted with floodplain forests, river channels, and herds of herbivorous dinosaurs, end quote. And that quote comes from the Independent article about it.
Cool. Yeah, it's kind of funny how big storms always pop up new fossils or pop down.
And last, Colin Trevorrow shared a photo of one of the dinosaur puppets for Jurassic World 3.
Nice.
This one's an animatronic baby Nasutoceratops, or at least that's what it looks like, that's finished and painted. And he has an earlier post that shows the dinosaur before it was painted moving around in a cage. And this is a guess that it's Nasutoceratops. People are saying that because it looks like the one that's in the short film Battle at Big Rock.
Gotcha. I wonder if it's a baby because somebody bought the Nasutoceratops.
I think Nasutoceratops is new to Battle at Big Rock.
Okay. I wonder why it's in a cage. Somebody catch the one that was at the battle there?
The cage didn't look like it was part of the movie. It was just they're testing it out.
Oh, gotcha. In case the puppet goes wild while they're testing it.
Or maybe later it'll be in one. It's hard to say.
Yeah. I'm glad they have puppets in there, though. I always like some practical effects, especially practical dinosaur effects. Before we get into our dinosaur of the day, just another reminder that if you could help spread the word about I Know Dino, that would be fantastic. It would really help us to grow and to reach more dinosaur enthusiasts out there. Obviously, the more listeners we have, the better it is for us for advertising and the easier it is for us to start new projects and go more places. So that really helps out a ton. And all you need to do to help us out is just tell one person about our show. You can listen to our show on Apple Podcasts, Google Podcasts, Stitcher, Spotify, TuneIn Radio, iHeartRadio.
We're everywhere.
Yeah, you can find the show anywhere that you listen to podcasts.
Yep. If you search Dinosaur Podcast or I Know Dino, we're there.
Yep. So anyone that has a smartphone that likes dinosaurs or science could listen to this show.
Smartphone, laptop.
Oh, true. You don't even need a smartphone.
Yeah.
So if you know anybody who's interested in dinosaurs or even just interested in science and wants to hear new science news, tell them about I Know Dino and you can help us out.
And now on to our dinosaur of the day, Haplocanthosaurus, which was a request from Dinosaur 4602, so thanks. It was a sauropod that lived in the Late Jurassic in what is now Colorado in the US and possibly Wyoming, and this is all in the Morrison Formation. It's a rare sauropod in the Morrison Formation, and it's one of the smallest ones as well, sauropods that is. Haplocanthosaurus is estimated to be about 49 feet or 14.8 meters long and weigh 13 tons.
This is pretty short. This is like Spinosaurus type length.
Yes. So yeah, relatively small body and also a relatively short tail.
Oh yeah, that makes a big difference because a lot of times the tail is like half the length.
Yep.
So it's probably still way bigger than a Spinosaurus. I guess at 13 tons, it's still a large animal.
Yeah. Yeah, usually it's the neck and the tail that really adds to length there. No skull was found, which makes Haplocanthosaurus hard to classify. It might be a close relative of Camarasaurus. They mostly found vertebrae. There's some debate over its phylogeny, but a 2015 study found it to be a diplodocoid or diplodocoid. There's two species, Haplocanthosaurus Priscus, which is the type, and Haplocanthosaurus delphi. The genus name means simple-spined lizard, and it was first described from specimens collected at the Marsh Felch Quarry in Colorado. So John Bell Hatcher was recently appointed curator at that time of vertebrate paleontology at the Carnegie Museum in 1901 and reopened the Marsh Felch Quarry in Garden Park, Colorado, where he and his team found two medium-sized partial skeletons of Haplocanthosaurus priscus. Hatcher named Haplocanthosaurus in 1903 as Haplocanthus, but then 4 months later he changed the name to Haplocanthosaurus because Haplocanthus was quote-unquote essentially preoccupied. It was the name of a fish that Louis Agassiz named in 1844. But that fish was spelled a little bit differently with a Haplocantthus instead of a Haplocanthus.
Huh.
So it turns out Hatcher didn't need to rename his dinosaur because the spelling was different, so Haplocanthus was valid. But petition was sent to the ICZN. They ruled in 1991 that Haplocanthosaurus was the correct name because of widespread use. It's the same thing they did when they ruled that T-Rex was the valid name.
You mean Tyrannosaurus?
Yes.
Rather than that other weird one
That nobody knows off the top of their head.
Most people don't know off the top of their head.
That's true. There are actually a lot of people who know. So Hatcher published a monograph in 1903 of Haplocanthosaurus and then named a second species, Haplocanthosaurus utterbacki, but that's now considered to be a juvenile Haplocanthosaurus Priscus. Haplocanthosaurus delphi was named in the 1950s based on a specimen nicknamed Happy. Happy was found in 1954 and estimated to be 72 feet or 22 meters long and weigh about 25 tons.
Well, it's like twice as big.
Yeah. And Happy was collected between 1945 to 1957 in Fremont County, Colorado. And these excavations were led by Edwin Delphs, who was an undergrad biology major at Yale at the time, and local rancher Joe Rode did the bulldozer work. They found Happy lying on its left side, mostly articulated. The skull was missing and neck was bent backward in that death pose. It was also missing other elements, including parts of the tail.
They got to go out there with a Geiger counter, radiation instrumentation, and see if they can find the skull.
Yeah, maybe. Maybe eventually scientists will go back to these spots looking for the heads.
Yeah, they've done a little bit, so could be done.
So Happy was about 35 to 50% larger than the holotype of Haplocanthosaurus priscus and then was named the new species, Delphsi. Also around Happy, they found turtle fragments, an isolated theropod tooth, and a crocodile. Happy is actually about 70% real fossils when they restored it. Yeah, it's the only Haplocanthosaurus that's complete enough to be put on display. And then the missing parts were modeled or cast from specimens in the American Museum of Natural History.
I don't know about the only one that's complete enough to display, because if you've ever seen Hattie the Hadrosaur, it's like two tiny bones on a big piece of wood. You can display incomplete stuff.
Well, I think Happy is the only one on display.
Yeah, it's obviously the most complete one, so that's cool.
Yeah. So you can now see Happy at the Cleveland Museum of Natural History, if you want to get an idea. There might be up to 10 specimens assigned to Haplocanthosaurus. Not all of these are confirmed yet, but one is nicknamed Big Monty. It was found in Montana. It's thought to be 110 feet or 33 meters long, but that one is controversial and there's not much known about the specimen. The whole story is it was found by Nate Murphy, who runs the private company Judith River Dinosaur Institute, which finds, excavates, and prepares fossils. And Nate is the one to estimate the 110-foot length. But Carrie Woodruff believes that it's smaller based on one of the 3-foot-long vertebra, which is not big for sauropods. And he thinks it's not a new species, but that it is a rare Haplocanthosaurus.
Interesting. Yeah, it's always tempting when you find a dinosaur, especially if you're going to sell it, to say, this is super long. It's over 100 feet long. And especially if you don't have the right limb bones to go along with it or a whole series of vertebrae, it's pretty hard to prove. And our fun fact of the day arose from something I've been wondering for a while, which is basically when you have dinosaurs moving between continents, we always talk about how sea level might have dropped, or, there could have been periods when the dinosaurs could move in between places. But how did sea level change throughout the Mesozoic when there was little to no ice any time during the Mesozoic? Because when we talk about human evolution, it's always like, well, there was a bunch of ice that year, so sea levels dropped, and then humans could go across the Bering Strait. But that can't be the way that dinosaurs were doing it, because apparently in the Mesozoic, there was virtually no ice. So it sent me down a deep rabbit hole, as often happens, or a Rictodromeus burrow, as we sometimes say.
When we remember.
Yeah. Real quickly, about a brief history of ice ages. There have been several major ice ages. None are in the Mesozoic, but one of them did end right before the Mesozoic started. It's called the Kairu Ice Age, or maybe Kairu Ice Age. It lasted from 360 to 260 million years ago. So it was 100 million years long. Really long ice age, but it wasn't an ice age like a snowball Earth. That was an earlier one where the entire planet was basically covered in ice. This one was a little bit more like the ice age we're in right now. We just had ice at the southern pole. There may not have been any ice at the North Pole during this ice age, though, because there wasn't any land near it. There were ice sheets covering much of Africa, India, Australia, South America, and Antarctica. And that's because they were all situated a lot closer to the South Pole. So it was a good place to form a whole bunch of ice. And obviously that dropped sea level quite a bit because there's all this ice on land, which means there was less water in the oceans. During that time, land-based plants, especially carboniferous trees, were mostly blamed for sequestering huge amounts of carbon, causing basically the exact opposite of what's happening right now. So these trees grew, they died and got buried in swamps, and they became the coal that we have today. So they were sequestering the carbon in sort of a permanent way, removing it from the atmosphere, and oxygen levels were really skyrocketing while carbon dioxide levels were plummeting. And as a quick aside, fossil fuels are mostly plants, not animals. So the whole thing with Sinclair being dinosaur bones, not so much.
Just their logo.
Yeah.
Which aren't bones. It's just a sauropod.
Yeah, it's true. Then after, a lot of millions of years of this happening, ice started growing at the pole. This increased the albedo of the Earth, which is the reflectivity. So the sun hitting the ice on the ice cap reflected off, which made the Earth even colder. And then it's a vicious cycle. Then more ice forms. It increases the albedo further. And that's how it can last for 100 million years. But the scientists do think they figured out how the ice age ended, which is pretty interesting. So eventually, temperatures dropped so much that the plants started growing slower and they weren't sequestering as much carbon. Then the high levels of oxygen also increased the amount of forest fires that were happening and therefore releasing carbon dioxide into the atmosphere. And termites evolved, preventing further carbon sequestration because the plants couldn't die and then get buried because they would get eaten by the termites first, releasing the carbon dioxide. So the first dinosaurs, after all of this was sort of getting back into more of a balance, had a similar sea level to us, but the sea level generally increased throughout the entire Mesozoic. So by the end of the Mesozoic, it was much, much higher than it is today. In addition to the sea level ice rising, the sea level also rose due to mid-ocean ridges and other volcanism filling in the ocean with landmass, basically, and pushing the water up. And high temperature water also expands, so the volume increases, further pushing up sea level, because at the end of the Cretaceous, I think it was like 10 degrees Celsius warmer than it is today. But the sea level can also drop, and this is the part I really didn't know about. So what can happen is if continents get relatively higher than the ocean, in other words, sea basins getting deeper from tectonic plate activity or lack thereof, it can basically cause the water to settle lower into the Earth's crust, and that causes the sea level to drop. So basically, if you think about like a subducting zone, different effects can push the floor of the ocean actually closer to the center of the Earth. It's really weird, but the oceans can actually get deeper, and then you have lower sea levels. Also, with the formation of lakes, that can also cause sea levels to drop. But this is all about global averages. There's also local area effects, so you can have sediments build up at rivers, or tectonic plate activity in a local area can raise or lower the local sea level, and then you can get more dinosaur movement. And that isn't saying anything about when continents touch and don't touch, too. That also allows them to travel. So there's a lot of ways sea level can change. We don't have a great handle on what the sea levels were like throughout the Mesozoic, especially in the Cretaceous. And that's just talking about global averages, let alone these local effects. So that's why scientists are constantly wondering when dinosaurs could have moved from place to place, and why we basically have to work backwards from how they look similar rather than knowing when the different places were possible to move between.
And that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe so you don't miss out on any new episodes. And please tell one person about our show. We'd really appreciate it. You can also join our growing community of dinosaur enthusiasts at patreon.com/iknowdino. Thanks again, and until next time.
Good day.